Welcome back. In the last video, we showed how the actuator could accommodate advanced database operations. And as with everything else, the actuator requires no logical instructions or advanced tech knowledge. In this next video, we're going to take a much closer look at set manipulation. You will also see the elegant way that the actuator handles groups of sets. Sets are among the things that make software programming so difficult. They require that you perform complex iterative loops, sometimes several layers deep. But here you simply say what you want and the actuator takes care of the rest. Our system of inverts is mathematically beautiful and, as you have seen, quite fun to use. Let's take a look. We'll start by looking at some fairly simple sets here. You can see how they're organized in the left here into these libraries. At the top you see self-referencing sets that maintain the same size and order after they've been manipulated. Things like percentiles, various types of rankings. And then below that you see certain types of subsets. They're organized into two types. The first type represents single tails of a set, for example the largest 10 elements or the smallest 10 and so on. There are also central values where you basically strip out the tails. And then down below here you can see various types of manipulations where we change the size and perhaps the order too. Things like sorted sets, selected subsets, reverse sets, unique subsets, sorted unique, and so on. What we'll do is we'll take a look at some of these over on the desktop here. You can see I've set up a simple standard program. I've already loaded these in so you can more easily see how they fit together. We're looking here at a set of numbers. If I click on this, you can see the number down there. And this represents a sorted set of numbers. If I were to open this up, you could see that the source for my sorted set is another set, which is actually called large n. That represents the largest n numbers from another set. If we open that up, we can see that the source for that large n is a no tails percent from another set. If we open that up, you can see what we've done here is we've stripped off the top and bottom 10% of this sample set. After we've stripped off the top and bottom 10%, we go to the large n and we then take whatever is the largest 15 elements of that. And then finally we sort it. As you can see, there's an awful lot of complexity involved in something like this, but it's actually fairly simple to specify it. You can also see that we have these letters A, B, C, D here that kind of identify these sets. They'll come in handy later. In the meantime, let's just look at one other variation. If I were to copy this here to the clipboard, I can then take something like a percentile here, put that in there, and I've had to pre-specify that this sorted set here is the target for my percentile. And you'll also notice that this is an A, type A, this is also type A, and that means that at some point later in the software program you can use these together and line them up. Let's now take a closer look at how some of these sets can be combined with other sets. You can see that we were working just then on the model. I'm going to jump over to the A tab where I've already set this thing up in advance just to make things easy. Over here you can see a database table that's been read in. You'll recall this from video 3b. And basically this acts against a stored procedure on an enterprise database. You can specify parameters in, it can give you parameters out. But what's interesting here are the data fields. And you can see that in this particular case we've got 4 data fields. And most notably each one of them has an E next to it. That tells us that these are all part of the same group of sets, and it means they can be manipulated together at the same time. Let's see a little about how we can do that. I'm going to go over to here and we're going to do something called, if I can find this, we're going to do some set regroupings. The first thing I'm going to do is I'm going to look at a multi-sort. In this case it's called multi-sort 2. If I click on this, it's first going to prompt me for the fields that I plan on sorting on. You can see primary attributes 1 and 2, and then there's the first twin. So in this case we're going to sort on a text field, and then we're going to sort again on another text field, and then the first thing we're going to load in there is going to be a number. And if I open this up, you can see now that these are all called F because we basically created 3 new types of sets. They don't necessarily have anything in common with sets that came before. And what we can now do is specify the source set for each of these. What I'm going to do is I'm just going to click on the employee last name. This is a text field. Employee first name, this is a text field also. And this third field would be a number. Now it's a bit silly, but we'll put the employee number in here just so you can see. So basically what we've done here is we've taken our 3 of these original fields that we read in from the database, and now we're going to be sorting them, and perhaps this one might be sorted in reverse. And this one might be sorted upwards. And then this third field here just follows the fortunes of the first 2. There are other types of set regroupings that we can do. I'll show you a couple more here. Let's just add one in. I'll show you a subgroup. This is a pretty interesting one. This allows us to sort on a primary field. Let's make it a text. But then the twins basically all have to be numbers. And basically what we do is we specify our original sorted set here. Let's make it this name again. It's a text field. But then the twin set that we're going to use is going to be a number. And let's pick the employee number from before. Put that down here. And what's interesting now is that we're allowed to manipulate this in various ways. And here you can see at the top, what I could do is I could say, let's pick the average. If I do that, then basically, as we're sorting this, we're forming subgroups, and then within each subgroup, I can choose to average, in this case it's an employee number, so this number here represents an average of those values. Let's close that up, and I'm going to show you one last variation, which is a generalized synchronized set. And this is a very powerful thing. What we're going to do is we're going to go back to the sets, and I'm going to look at let's see. Let's pick the large nth from before. I'm basically going to put this over here, and if I hit this cog button, it prompts me for my primary attribute and my first twin attribute. This first one is going to be a number, and this second one is going to be a number. And now basically what I can do is I can manipulate this one set. Let's just pick these numbers here, put them in here. I can manipulate this one set by taking the largest, let's say, 3 numbers from that group. And what it'll do is it'll cause this one to follow the same fortunes. So for example, if I were to select this number here, put it in there, then by picking the 3 largest here, it's going to give me the corresponding ones, the corresponding values of this field. And obviously, as you can imagine, we can do all kinds of manipulation with any of these things. Just to give an example, if I were to come all the way down here and pick something like this, this is a singleton. This basically represents an annuity. If I was to say specify 8% for that annuity, and the number of years of the annuity, I know it's silly, but if we put this one in here, what we now have is another set of numbers that represents a set of annuity values that are all the same group E as you saw from these inputs. So these fields can all be combined in outputs, or written out to databases or files, or so on. So to summarize, you've just seen a variety of manipulations to individual sets as well as to groups of sets. Inverts easily represent sets with just a few tweaks to the basic design. Together with all of the other 1200 inverts, they enable you to effortlessly build software of great complexity, no programming needed. In our next videos, we will unveil the crown jewels of the actuator, Monte Carlo random models that underpin financial pricing, hedging, and risk management. Thank you for watching, and we'll see you next time.